In this video, we'll be seeing a problem based on serializability of a schedule. It would be similar to the problem which we saw along with the algorithm in the previous video. So just that we are discussing an additional problem. So for university, how the question is asked would be like, so you will be given a schedule like this and asked whether this schedule is serializable. You need to check it using a precedence graph method. So that is the algorithm we saw in the previous video. We saw how we can construct a precedence graph given a schedule of transactions, and if there's a cycle coming in the precedence graph, we conclude that it is not serializable, and if there's no cycle coming in the precedence graph, we conclude that the schedule is serializable. So that is the standard procedure. So for exam, actually you will be given a schedule like this. It would be comma separated. The schedule would be comma separated. You won't be directly given a table like this. Most probably you will be given a schedule by comma separated values. So if you are given a schedule like this, let's see how to construct the table. We had seen constructing a table corresponding to a schedule when we had discussed how to find if a schedule is recoverable and cascadeless. So it's the similar procedure we follow over here. So before that, in the schedule, we need to identify how many transactions are involved. So there is R3 in this, so 3 transactions would be involved anyhow. 1 is there, 2 is there, so 1, 2 and 3. So there are 3 transactions involved. So in the precedence graph, we will be constructing 3 nodes because since there are 3 transactions, we will be constructing 3 nodes in the precedence graph, T1, T2, T3. So there will be 3 nodes in the precedence graph, and in the table there will be 3 columns, T1, T2 and T3. Now let's see how to write the operations as scheduled in this table. So first one is R3Y. So if it is R3Y, it means the read item Y in third transaction. So we write a read item Y corresponding to the column third transaction. Then it is R3Z, so we write read item Z in T3. Then it is R1X, so we write read item X in T1. So this 1, 2, 3 denotes the transaction it belongs to. So we write read item X in T1. And note that this read item X comes after this read item Z. So we write it below this. So that is the order to be followed. Next it is W1X. So we write right item X over here. Next it is W3Y. So right item Y over here. Next it is W3Z. So it is right item Z in T3. So similarly, you can just see that the schedule has been written down in this manner as a table. So now the next step is to identify the conflicting operations. So the first conflict, the chance for first conflict starts from here because before this there is no other transactions to conflict. So we start from here. So read item X, we need to see whether there is a write item X anywhere before this read item X. There is nothing, so there is no conflict for this operation. Then write item X, there is no read or write item X before in any transaction, so this does not conflict. Then we go to this transaction, write item Y, we need to check whether there is a read item Y in any of the transaction before. No, there is not. Then write item Z, so we need to check whether we have a read item or write item Z in any of the other transaction. Now don't confuse this with the same transaction, okay, like write item Z is there over here, read item Z is there in T3. So we should be actually checking for conflicts in other transactions. So write item Z is not conflicting with any of them. Next comes read item Z. So read item Z, we need to check for write item Z in T1 or T3. So in T3 we have a write item Z occurring before that. So these two are conflicting. Read item Z in T2 and write item Z in T3. They are conflicting. So how would the edge come? It would be from T3 to T2 because this comes first, then this. So we have an edge from T3 to T2 and it is because of Z. So as of now we have Z only. We will be seeing how Y came. So T3 to T2, it is based on Z. Now next over here we don't have any conflict. So don't forget to check for conflicts in both the other transactions. Then we have this read item Y coming over here. We need to check for conflict with T2 there is no conflict. In T1 we have right item y. So there would be an arrow from T3 to T1 based on y. T3 to T1 this edge is created and y is written. That's how this edge T3 to T1 came. Now next we were dealing with this read item y, right? So read item y we have dealt with. Next we need to deal with write item y. So this write item y would be conflicting with write item y over here or read item y over here. It can conflict with both write item y and this read item y in T3. So anyhow there will be a edge from T3 to T1. So already we have drawn that edge T3 to T1 based on y, because based on this read item y that edge was already constructed. So you need not draw anything else. So if this was new, we would construct or draw an edge from T3 to T1. So next we are coming to T2. So T2 has a read item y and it conflicts with this write item y in T1. So there would be edge from T1 to T2 based on y. So that is how this edge T1 to T2 came and y is written over there. Then read item y with here we have write item y. So there would be an edge from T3 to T2 based on y. So that is how y came on this edge T3 to T2. T3 to T2 was constructed earlier based on z. Now y is also added on that edge. Next we have write item y we take that conflicts with T1. So T1 to T2 there should be an arrow. So T1 to T2 already based there is an arrow. If y is not added, add y based on y. Then with T3 write item y would conflict with this write item y. So T3 to T2 already the arrow has been drawn or the edge has been drawn. So we take the next operation read item x. So that conflicts with write item x in T1. So T1 to T2 there should be an arrow which has already been constructed, and in T3 this read item x would conflict with nothing. Then the last one write item x should be conflicting with write item x in T1. So T1 to T2 an arrow should be drawn based on x which is already drawn. Then with T3 write item x there is no conflict. So this is the final precedence graph we are getting after considering all the operations up to the end. So we can see in this there is no cycle being created. So if you have any confusion, you can see T3 to T1, T1 to T2, but there is no arrow from T2 to T3. So it is not a cycle. So there is no cycle created in this graph. So you should be familiar with checking a cycle in a graph. So there is no cycle created in this graph. So since there is no cycle created in the precedence graph, so we can say this schedule is serializable. So that is how you can approach this problem for the exam, and you can also based on the mark write the algorithm if required. Otherwise you can draw such a table, draw the precedence graph. You may just explain in words how, why or when we draw an edge from one node to other in your own words, and you need to highlight this conclusion of yours, like based on the precedence graph, if there is a cycle, what is the result, what is the result if there is no cycle, and you should conclude whether the schedule given is serializable or not. So in this there was no cycle. In the previous example, I will just show you the previous example, and this was the previous example we dealt with. In that there were two cycles. How to identify cycles? Like T1 to T2 it goes, T2 to T1. So this is a circular circuit like thing. So that is a cycle. It has one more cycle, T3 to T1, then we go from T1 to T2, T2 to T3. So if we go start from one edge and come back to that edge via other nodes, it is a cycle. So hope this problem is clear to you. Thank you.